So in this video I'm going to discuss Codeforces round 954 rated for division 3. So I will be solving till problem F in this problem statement. So let's start with problem number A, that is x axis. So in this question we will be given three coordinates x1, x2 and x3. Okay. Now you have to choose a point such that it is on x-axis and the point may coincide with any of these three given indexes, and also the total distance between from this number to any of these three numbers should be as small as possible, which means if you choose any number, any index as y, then distance between y and x1, distance between y and x2, distance between y and x3 should be as minimum as possible. Okay, so the answer is very much simple. Just sort the array and find the distance between middle element and first element and middle element and the last element. So that's how you can solve problem number A. So let's now discuss with problem number B, that is matrix stabilization. So in this question we will be given a matrix. Okay, and what we can do, we have to choose a index which is which is greater than, I think so it is greater than, right? Where's the condition? Okay, which is strictly greater than its all of its neighbor. And what is a neighbor? Neighbor is that index which is adjacent to that index, which means the neighbor of 4 is 8, the neighbor of 4 is 5, and the neighbor of 4 is this 5 also. If my current number is greater than all of my neighbors, then we have to decrease that number by 1. Okay, hope so you got this question. Now what we can do, we have to use this operation infinite number of times. Till then you cannot make any operation, which means all of your numbers are smaller than or equal to to which is for is any of its neighbor. Okay, so hopes you got the question. So you have to tell them what is the resultant array would look like. For example, if this is my array, now this array is greater than all of its neighbor because 3 has only one neighbor, that is 1. If you decrease 3, but it will become 2. If you decrease 2, it will become 1. So you cannot make any more operation in this array. So this will be your final array. Similarly for this, you know that your this 4 is your uh, that index which you have to decrease because it is greater than is both of its neighbor, that is 3 and 2. So you will decrease 4 by 1. So now you can see there is no such index which is strictly greater than from its all of its neighbor. Similarly for this also you can check the question. Okay, so how to solve this problem? So the question is very much easy. If you make your current number, for example, if you select that number which is on which you have to apply the operation, so till which point you will apply operation on that number? Till that index is equal to its largest number, right? For example, if I take the example of this question, like this example, that is 7 is greater than 1 and 4. So till what point you will apply operation on 7? The point where my 7 becomes equal to 4. So you can see that here my 7 is now 4. So you will not make any operation on this 4. You will now choose any other index which is greater than from all of its indexes, that is 10. So till what point you will make operation on 10? That is till my 10 becomes equal to 8. You can see my 10 is now 8, so you cannot make any more operation on the 10. So what is that number? But that number is the maximum neighbor, right? So what you have to do, you have to find the index which is greater than from its all of its neighbor and make that index equal to its largest neighbor. So by doing this operation on each and every index, you will get your final array. So if you want to see the code is also easy. What I am doing, I am finding whether my current number is greater than its all of its neighbor. If it's not greater than in any of its neighbor, then I will skip the iteration. Else what I will do, I will find the maximum neighbor and make my current number is equal to that maximum. That mean is not equal, I have chosen the wrong number, no, wrong naming. It would be maximum number. So you will make the current number as a maximum number. So that's equals solve the problem number B, and this is your code. You will get the code in the description also. So let's now discuss the problem C, that is update queries. So in this question, you will be given a string s of length n. Okay. Now you are also given a array of length m and a string of length m also. And what you have to do, you can make in each and every query you have to do, you have to select that index of I from that array which is given to you and make s of index of I equal to c of I. Okay. Hope you have got this equation. What you can do, you can shuffle any both of the arrays. You can shuffle my first array also, and you can shuffle your second array, means that string also. Now what you have to do, you have to shuffle this array and this string in such a way that after performing the queries, you will get the minimum you will get the lexicographically smallest string s. Okay, because you're at then you're performing operation on s only. Let me repeat, you can shuffle your that array and that string in any such configuration, such that after performing that number of queries or that number of operation, your final resultant s is as small lexicographically as possible. So how to solve this problem? So I think so problem is very much easy, but why? So let me take this example. Okay. Okay, so you know one thing, that you will perform operation on first index. Okay, you will perform an operation on second index, and you will perform operation on fourth index. Okay, okay. Now you know one thing. If none of your index, if any of the index is not included in this array, that is 3, then that 3 will never be changed, which means this O in the final array, this O will be O only, which means you cannot modify this O. Okay, hope so you got this point. Now you want to make the string as small as possible. Now if you want to make string as small as possible, then what you will do, you will start to decrease your point from the first index, which means if your first index equal to b, or your first index equal to if your first index equal to c, or your first index equal to b. Okay, now tell me, for example, if it is no matter what is this, if it is a and if it is z, now tell me what is the smallest lexicographical string, that is b only. The string starting with b will be lexicographically smallest string. Hope you got this point. Which means if your lowest index is as small as possible, then your rest index does not matter, which means you will always try to put as small as character at the lowest index possible. Okay, so now what you can do, what are the available characters to you, that is I will write it in the sorted order, that is c, w and z and z. Okay, now you also know one thing, if any of index is in this array, then that index would be modified. You cannot skip that index. Okay, so which means if any of the index is this in this array, you have to put character from this array. Okay, you cannot take the original character. So what is the smallest number? The smallest number is c. Map to c. No, cut the c. Now smallest number is w. Okay, cut the w. Now smallest number is z. Now cut the w also. Now you will ask me where to please put this z. You can put it anywhere. That does not matter at all. Hope you got the point. Why I am saying it like this. Okay, because you can see the one is coming two times, so you can simply you can make a one as z in the previous manner, because at then you will make a one as c. So the previous method does not, the previous query does not matter at all, because you are overriding the same query. So just write the index like this. Now what would your final string? The final string would be like c, w, and your third index would be same, because you are not modifying third index, that is o, and last is z. So c w o z, is that the answer? C w o z. So that's how you can solve the problem number C. Let me repeat it again. First of all, write all the indexes which are in the array, sort them, sort the given C array also. Now map each and every character from starting after sorting to each and every index from after sorting from the starting. Okay, hope you got the point. Now map each and every index. The leftover indexes would not be mapped to any of the number. Write them as it is and write the corresponding smallest number in this manner. Okay, hope so you have got the point and know how to solve the problem now. So let me show the code also. What I'm doing, I'm simply hmm, hope so this is C question only. Yes, this is so only. First of all, take the your current string s, then take your current next array. I'm decreasing the index because of zero based indexing. Now take the input of C array. Great. Now sort the C array. What I'm doing here, sort the C array. Now map each and every number in a character form. Okay, map each and every number. Now what you will do, starting from the index, you know one thing, this map will sort the indexes based on the increasing order. Okay, because this is a property of map. Now what you will do, from the smallest index you will start mapping it from the your given array C. Because you sorted the C also, you will get the smallest character as possible as early as possible. Now if your current index is included in that array, simply put the mapped character, else put the original character. So that's how you can solve the problem C and print the answer. So let's now discuss the problem D, that is mathematical problem. So this question is very much interesting. I will tell you why. So in this question you will be given a string. Okay, you will be given a string. Now you have to put total n minus 2. Let me repeat it again. You have to put total n minus 2 symbols in between the numbers. You cannot. So let me take the array here. Okay, now what you can do, you have to put total n minus 2 characters in between the indexes, right? You cannot put a character here, you cannot put a character here also. You know the reason why, because there will not, because you, so let me repeat again, you cannot put a character here, you cannot put a symbol here. Okay, now there are two symbols available too, that is plus and multiply. Okay, so which means if I put a multiply over here, which means you will multiply this 19 with the rest of the equation, right? Okay, now treat them as a number, not as a character. So this is not 1 and this is 19. Okay, now you have to put total n minus 2 symbols in between the string. Now what is this? I don't know why. Okay, how so this is vanished. Okay, now you have to put total n minus 2 number of characters in this string. Okay, great. Now you will notice one thing. What does n minus 2 signifies? N minus 2 signifies that after putting the symbols in between the array, there would be only one pair, there would be only one number left in the string, which would be having two characters. For example, it is 21. Now if you put a symbol over here, here, so total number of symbols would be n minus 2. Okay, let me take a smaller example. For example, if you have string like 2, 1, 3, 5 and 4, and for example this. So what is a 1, 2, 3, 4, 5, 6? So length is 6, which means you have to put total number of 4 symbols. Okay, if you put total 4 symbols, which means either you will put symbol here, 1, here, here or here, but you cannot put here because 4 symbols are already occupied. Which means at the end you will be left with one pair, which would be having total number of two characters, and rest each and every character would have only one character. Okay, if you put like if you put your symbols in this manner, let me take another configuration. If you put your symbol, one symbol here, one symbol here, one symbol here, one symbol here, in this case 21 is there. Now rest of the numbers are single, single, single. Okay, hopes you got the point. Which means at the end your one number would be two digit and rest of the numbers would be one digit only. Okay, great. So let me now just talk about some base cases. So one base case is like that. If for n is equal to 2, if for n is equal to 2, just simply write the answer, just simply write the given string, just simply return the given string. Okay, great. Okay, just simply return the given string. Now another base case is like that. If your string contains a 0, if your original strings contain a 0, then answer is 0. But why? Because let me remind you, what are the two operations with you? The two operations are plus and multiply. Okay, if your any of the number is 0, if your any of the number is 0, just make all of the symbol as 0. Just make all of the symbol as 0, which means like for example 1 3 0 2 1 2, that is 7. Now this contains a 0. Now you will, let's suppose you will map for example, now you know one thing, you will have one number which is of two digits. So just don't include 0 in that two digit number. Just include any of the other digit which would be two digits. So let me include this number. For example, this is two digit. Now just choose multiply symbol, just choose multiply symbol only at each and every indexes. Okay, now choose multiply indexes at each and every index. If you choose like this, now your final answer would be 0 only. Okay, now the two base cases are like that. If your n is equal to 2, simply return the s. If your string contain 0, then simply return 0 only. Okay, great. Now you know one thing. Now there are two operations with you. There are two operations with you. One is plus and another is multiply. So you will tell me that I will always choose plus and plus because multiply is increasing my number. Okay, the goal is to minimize the number. But you will say one thing, you will always choose a multiply plus operation because multiply will increase the number. But no, there is a one case in that where you will always use multiply. What is that case? For example, I am having a number like 3, 3, 5, 1 and 2. Now I will now forget that adjacent condition for one time. Okay, now you will say that I will choose plus here, plus here, plus here, and plus here. Okay, now what is the final answer? That is 8 plus 3, that is 11, that is 12, and that is 14. In this case, 14 is your answer. But in case, but if I tell you, if you with one, you will never choose plus one. With one, you will always choose multiply symbol. Okay, but doing this, what is my final answer? That is 6. Okay, 6 plus what? 6 plus 8. What is this? I think so. This is also 14. This is also 14, but But you know one thing, let mm, that is 12 and it is getting okay. So let me take another example. This is given the same way, because you know one thing, that multiplying one with any number, that you know one thing, multiplying one with any number will give you that number only, but adding 1 with any number will give you num plus 1. Okay, so that is the reason. If you're having a 1, then I will multiply it. If you're not having 1, if the current number is not 1, then I will always add. Okay, hopes you got the position. Hope you got the point. If my current number is 1, then you will always use adjacently multiply only. If your current number is not equal to 1, which means that number is not equal to 1, then you will always use addition. Okay, then you will always use addition. Because if you take an example of 2, because if you take an example of 2 and minimum number as 2 only, minimum number as for example 6. Okay, 6, 3 plus 6 is equal to 5, and if you choose multiply, 3 into 6 is equal to 6, uh, 3 into 2 is equal to 6, and 3 plus 2 is equal to 5. So what is the beneficial? Adding is a beneficial. But if you take this case, 3 into 1 and 3 plus 1, okay, that is equal to 3 and that is equal to 4. So that is so it's always beneficial to take multiply with 1 and accept 1, choose 2, choose plus with any other number. Okay, great. Now what is another question? How to choose this, how to choose that in adjacent index, how to choose that adjacent index which will be together at the end, which means how to choose that number which would be of 2 digits. So the hint is in the problem. What is that hint? Your n is 20 only, which means you can brute force for each and every adjacent index. You can brute force for each and every adjacent index. And if your current number is 1, just multiply it. If your current number is not 1, just plus it. So for each and every adjacent index, say repeat the operation and find the minimum answer. If you show the code is also easy. Now if my n is equal to 2, just simply return the string. Okay, you can neglect this part. You can, if n is equal to 3, then I can also do the operation, but I am doing like this. Let me repeat again. If your n is equal to 2, just simply return the original string. I'm just removing the redundant 0 for the first index. Okay, now what I'm doing, what I'm only doing is like that. If my string contains a 0, if my string contains 0, then simply print 0 and return from here only. Else, else what I will do, I will try to choose each and every pair as adjacent index that would be together at the end. Okay, for current iteration, let my that adjacent index would be I and I plus 1. Okay, now what I am doing, I'm iterating in my array. Okay, great. If my current index is that index from where which my adjacent index is starting, from which I'm at this index, which means my two this will be pair. Okay, which means what I'm taking. If my j is equal to index, which means my this number next number would be pair. I'm just calculating that pair and adding it in my sum. Okay, adding it in my sum. Okay, great. And j plus plus. Okay, if my current index is not equal to that index, which means I'm for example I'm on this index, or I'm on this index, or I'm on this index. Okay, great. If I am on any another index except that adjacent index, then I will check for a condition. If that index is not equal to 1, because for 1 I am only multiplying it, by multiplying with and by multiplying 1, that is not contributing anything in my answer. I'm just checking condition. If my current number is not equal to 1, then simply add that number. And minimum of all the checking edges number. For example, this is number 3 1 3 4 5. First of all, I will take this adjacent number and find the answer. Then I will take this adjacent number and find the answer. Then this, then this, and then this, and the minimum of all these numbers would be my final answer. Okay, great. So that's how you can solve the problem number D. Now let's move to problem number E, that is beautiful array. Okay, great. Is it beautiful? So what is the question asking you to do? So you will be given an array, okay, an integer k. You have to make it beautiful in the least amount of operation as possible. Okay, great. Now what is the operation? What is the operation? What you can do, you can shuffle the array, and second what you can do, you can add k in any of your numbers. Okay, and what is a beautiful array? Beautiful array is that array in which your first and last number are equal, second and second last number are equal, third and third last number are equal. Okay, so that is a beautiful array. And what is the operation? You can shuffle the array and you can add k in any of the number, and k is given to you. So what is the minimum operation required? So how to solve this problem? So let me tell you the intuition. So let me tell you the intuition. For example, you are given an array like this. I am taking this index. Okay, you are given this index. Now first of all, you will know one thing. When you can make two index equal. When can you make two index equal? By adding k in that. If that number modulus k is equal to that number modulus k. For example, you are having two numbers a and b, and I told you to make a and b equal by adding k in that. By adding k in any of these two numbers. Then how you can make them equal? The only possible way is such a way like that a minus b minus a should be a modulus of k, which means a b minus k modulus k should be equal to 0. Okay, because then only you can add k in any of this number. I can take absolute value also. The absolute difference between a and b should be a modulus of k. Then only you can make a and b equal. For example, let me take example of, for example, 11, and let me take it 6 4, let me take it 5. Okay, in k is equal to 3. Now 11 modulus 3 is 2. Okay, now 5 modulus 2 is 3, or 5 modulus 2 is all 5 modulus 3 is also 2. Now you know one thing, by adding 3 and by adding 3 two times in 5, you will get 11, which means this is a valid pair. Okay, which means if I am giving you 5 and 11 and told you you can add 3 any of this number any number of times, and tell me, can you make this element equal? The answer is yes, because the difference between them is a modulus of k. Okay, hope you got this point, because 5 minus 11, what is this? 6, and 6 modulus 3 is equal to 0. And you know one thing, if difference between them is modulus of k, then by adding k in any number of times, you can make them equal. Okay, so this is one thing. Now moving to the next point. What you will do, you will map the numbers. You will map the numbers to the indexes. So let me remove this part. You will map the number to the indexes. For example, mm, okay, for example number is 3, which means any number modulus 3 can be equal to 0, can be equal to 1, and can be equal to 2, right? Okay, so now remember one thing, that 5 and 11, both modulus 3 is equal to 2 and 2, which means if the both number modulus 3 is the same number, then only you can make them equal, else you cannot. Which means, if I'm giving you 5 and 12 and told you you can add 3 any of this number, can you make them equal? The answer is no, because 5 modulus 3 is 2, 3 modulus 5 is 2, and 3 modulus 12 is 0. These are not equal, which means you cannot make them equal also. Okay, great. Now for 0, what are the numbers from which by modulosing 3 you will get a 0? That is 3, okay, that is 9, okay, that is 9, and that is 18, and that is 30. That is 18, and the number is 30 also. Okay, great. Now for 1, now tell me for 1. That is 10, okay, that is 10. Now that is 22, okay, that is 22. Now that is 20, no, now for 2, that is also 2. Now 14, that's 14 also. Now 17, 15, yes, 17 also. Okay, it will be 17, 17 also. Remove 2, remove 14, remove 17, is it 20? 18, yes, 20 also, 20 also. Now you got this array. So you check, uh, pick the correct number. The answer is 14 in this case. Wait a minute. Hmm. 1 2 1 1 2. What is the size of the array? I am missing some number. 13 3. What array I have picked? 18 30. Okay. Now these numbers are below here. Okay, now what is 1? Now 1 is also come here. Okay, 1 will also come here. Now for 4 will also come here. Now for 28, 20 is a modulus of 3, yes or no? No, so 28 will come here. Okay, great. Hope so you got the point. Now you one thing, you can only make equal, you can only make these elements equal. You can only make these elements equal. You can only make these elements equal. Okay, got it. You can only make these elements equal. Now tell me one thing. If your array length is 4, now if your array length is even, if your array length is equal, then you have to choose, you cannot place any of these number in the middle of the array, because in the beautiful array, if the element is in middle, you can skip the element, because that number is already equal to that number, so you can skip that number. And if your array size is even, is even, then any of these numbers cannot be that middle element. Okay, of your code domain, which means you have to use operation on these numbers at the end. Okay, you have to use operation at in numbers at the end. Now tell me one thing, how you can get the minimum possible numbers? By choosing them greedily. Okay, you will make 1 and, okay, you will make 3 and 9 equal, you will make 8 and 30 equal. Okay, because this is the only smallest possible configuration. First of all, sort the array. Remember one thing, first of all, sort the array. Now one thing, tell me, if you choose these two indexes, then you choose these two indexes, what is your answer? The answer will be huge. The minimum answer you can get by choosing these two indexes and then these two indexes. By choosing these two indexes, what is the answer? So the answer would be, so how many times you would add 3 in these 3 to get a 9? That is total number of 3 times. Okay, total number of 2 times, because 3 total number of 2 times. So right to here. Now how many times 3 you would add in 18 to get a 30? That is total number of 4 times. Okay, great. Now I will tell you the odd indexes later. Now for this, if you choose these two indexes or you choose these two indexes, the answer would be greater. To get the minimum possible sum, then you have to choose adjacent indexes in the sorted order. So what is the uh, total number of operation, which means how many times you will add 3 into to get the 14? That is 4 number of times. How many times you will add 3 in 17 to get 20? That is only 1. Okay, got. So that is a fixed answer. So you cannot, so this is the number of operation which you have to use, which you cannot neglect, Okay, great. Now but for the odd index, so let me sort the array first. The sorted array would look like 1, uh, 1, 4, 10, 1, 4, 10, that is 22, and that is 28. Okay, great. Okay, great. Now what you can do, in the odd array, you can skip any of the number, which means at the end of the array, remember one thing, if the array size is odd, if the whole array size, if the whole array, this is the index, this is a case, if the whole array size is odd, at the end there would be one index in the middle, which is equal to himself only, which means you can skip any number. You can skip any one number in the odd array. Okay, but in the even array you cannot neglect, because that's as a even, you have to make a pair. But in odd index you can neglect one number. So what you can do, you have to brute force all of the points. First of all, let me try to neglect this array. If I neglect this point, then the sum of this would be my answer. Okay, if I neglect this, then sum of this and sum of this would be my answer. Okay, if I neglect this, then sum of this and sum of this would be my answer. Hope so you got the point. If I neglect this, then the sum of this and sum of this would be my answer. And at the end, if I neglect this, then sum of this plus sum of this would be my answer. And the minimum of all the cases would be at the end, would be added in final answer. Okay. Now for this case, let's suppose you're taking 10. You are neglecting 10. Now what is the number of operations required to make 1 equal to 4? That is 1. Now number of operation for this, that is 2. Yes, that is 2. Now what is my final answer? It is 2 plus 2 6. 6 plus 4 10. 10 plus 1 11. 12 13 14. 14. Is your 14 answer? Yes, 14 is my answer. Hope you got the intuition how you can solve the problem. So first of all, let me repeat it again. First of all, create a map, and in a map, put all of the numbers together which are having the same modulus with the k. Okay, now if your array size is even, then simply make the operation of adjacent numbers, this and this, and add that in your answer. but if but if your array size is odd, then you will use you will choose another way. Okay, let me tell you that way in later. Okay, but there's also one thing. If you're having two such indexes whose length is odd, then answer is no, because in this array you will neglect one element. and you are also having one array whose size is odd. Let me check a hypothetical array. If you are having these two arrays whose size is odd, then you will neglect one element from this. You will also neglect one element from this, and you cannot make this element equal to this element because modulus of both these number are not equal. If modulus of both these elements are not equal, you cannot make them equal. So in that case, answer is no. Which means if if you're getting two arrays whose size is odd and they are having different modulus with k, then answer is no. But if you're only having one array or zero array whose size is zero with the same modulus of k, then you have to do one thing. That is one thing. And what is that one thing? That is, you have to skip each and every indexes. You have to try skipping each and every index and find the answer. You can simply use a prefix sum suffix sum array for this. First of all find the answer in the suffix sum array. That is answer till index from the starting of the array. For example, if this is the array given to me, that is 1, 4, 10, 22, and 28. Find the answer in this array. Find the answer in this array. So let me tell you how. So answer till this point is 1. Okay, great. Answer till this point is, what is it? 1 plus, that is 12, that is 5. Okay, great. Now I'm now getting in reverse order. Okay, in reverse order, what is answer till this index? So let me take it this index till this index. Now in the reverse order, what is answer till this index? That is only 2. 2, is it 2? Yes, it is 2. Now what is answer till this point? That is this plus this, that is this 6, 6, 2, 2 plus 2, 4. Okay, great. Now if you skip 10, then the answer would be 1 plus 2, that is 3, because answer till suffix and answer till prefix. This is suffix array, this is prefix array. Answer is prefix, answer is suffix, and by skipping the current number, that is your final answer. Okay, because that's how you can get the answer. So if I am skipping this point, if I'm skipping, so if I so let me take another example. If I'm skipping this index, then there is no prefix in this case. You will only take suffix. So what is suffix answer? Suffix answer is 4, which means if you skip 1, you will get a 4. But if you skip 10, you will get a minimum as 3. You will get a minimum as 3. So the minimum of all this possible combination will give you the minimum possible case by skipping each and every index. So hopes you got the intuition and problem part. So let me show the code. The code is also easy. I repeat this in every case. So first of all, create a map for I modulus k and push that a number, which means for each and every I modulus k, push the I in the answer. Okay, push the I in the map, which means the for each and every vector of array, all of the number would be having the same I modulus k. Okay, great. Now iterate in that map and sort the array first of all. Okay, great. If your array size is odd, if your array size is even, then answer is simple. What is that answer? You will simply add the adjacent numbers, divided by k, and just iterate 2 times. Because if your array size is 2, if your array size is even, you will simply take these two indexes. You will take these two indexes and move to the next index. And how I can get the number of operation? By subtracting the adjacent number divided by k. Okay, great. Subtracting the adjacent number divided by k and skip one index. Okay, but if your array size is not equal to, if your array size is odd, then you have to make two arrays, that is prefix and suffix array. In prefix array, you will simply make that you will simply make maintain a k. You will simply maintain a differences. You will simply maintain the sum at the current point. Okay, maintain the current point and make a suffix array which will be containing the which would contain the sum at current index in the reverse order, in this order. In suffix array, in the prefix array, it will be in this manner. In suffix array, it will be in this manner. Okay, creating the both of the arrays. You can see the creation part is also easy. What I am doing, I am simply adding the previous prefix plus I minus I j a of j minus a of j minus 1 divided by k. That is the adjacent numbers, and simply moving 2 times, and simply decreasing 2 times in the suffix part. And now you will consider for each and every element. You will consider by removing each and every element. If I am removing the current index, then what is the sum at that index? That is prefix plus suffix. But if you are on the first index, then your only answer will be contained in the suffix only. And similarly, if you are on the last index, the answer would be in the prefix array only. So you got the point. So by by trying removing each and every element in that odd array, the minimum possible sum, you will add the final answer. Now you will notice one thing. I have a condition. If I'm getting two times in the same condition, which means if I'm getting two times odd array, then simply print -1 in return. Okay. Else that is the answer. What is the answer? Answer is minimum of odd indexes and fourth even indexes. The answer is simply simple by choosing the adjacent indexes. Okay, great. So that's how you can solve problem number E. So let's now take the number F, that is non-academic problem. So in this question we will be given a graph and you can remove any of the edges. For example, if this is graph given to you, if you remove these indexes, if you remove this edge, if you remove this edge, then find the total number of connected pairs. Then find the total number of connected vertices. Now what you will have to do, find the minimum number of connected vertices at the end by removing any one of the edges. So okay, if you remove this edge, now you know one thing. Now initially your graph would be connected and undirected. Okay, now if you remove this edge, still your graph is connected. Then the answer is the answer will not be decreased. The answer will be original answer. So if you don't remove any of these indexes, then what will be answer? The answer would be n into n minus 1 divided by 2. Okay, but why? So you can take, if you don't remove any of the edges, then your graph is connected by default, which means your every edge, your every vertex is connected to each and every vertex. So if your every vertex is connected to each and every other vector and another vertex, then total number of connected vertices point would be n into n minus by 2. That is simple permutation combination. Okay, hope you got the point. Now if I remove any, if I remove this array, if I remove this edge, still my graph is connected, still my whole graph is connected, then your answer would not be decreased. But if I remove this edge, then my graph would become disjoint, if with which my graph will be disconnected into two components. Okay, if my graph is disconnected into two components, the number of vertices in one component, the number of vertices in another component, adding the both of the answer, any adding answer for both of the component and find the minimum of that would be my final answer. But how to get the answer? So what you can do, you take each and every index, teach each and every index, you find the number of vertices behind that. For example, till 3, till 3 you have 3 indexes. Okay, now you one thing, if you remove this index, if you remove this edge, then total number of connected components behind 3 is 3. Okay, and now let me take the graph over here. Okay, it is here. So if you remove this edge, now you one thing, total number of edges are 6. Total number of edges are 6. Total number of edges are 6 with you. Now you one thing, till 3 you are having 3 indexes. Till 3 you have 3 indexes. Now by removing this edge, you know one thing, by removing this edge, the number of vertices in other component would be n minus 3. That is n minus edges at that edges till current index. Okay, great. Now what will be your answer? The answer is the edges till the number of vertices till this point, that is 3 into 2 divided by 2 plus number of vertices in another component. And what is that count? That is simply n minus 3. That is n minus number of connected current component, minusing it by n, that is again 3. That is 3 into 2 divided by 2. So the minimum of all these equations would be my final answer. So what is thing to remember? For till each and every index, find the number of vertices behind that. Find the number of vertices behind that. Okay, great. By finding that, iterate on each and every index. Iterate on each and every edge. Okay, I am iterating on each and every edge. Okay, try removing that edge. If I remove this edge, then the number of vertices in previous edge would be this much, and the number of vertices in next edge would be n minus number of vertices in previous component, that is n minus 3. That is 3 only. So the minimum of these two will be my final answer. But the question is how to find the number of index in previous component. You can easily find it by DFS. So I will show the code for the DFS. So these are you can understand this. This is very much easy code. So I have told the main intuition. I have told the main intuition of this problem. So if I repeat it again for this index, where is that? Okay, this is the point. Okay, great. Now if I remove this edge, I know the component till 4 is here is 4. Okay. Now my total number of component in this case is 4 plus 3 7 plus 3 10. Okay. Now my component till here is 4. If I remove this edge, I know one thing. Total number of vertices. Another component would be n minus 4. That is 6. Okay, that is 6. Now tell me how many vertices are connected. That is 4 into 3 divided by 2. In another component, what is that number? That is 6 into 5 divided by 2. Okay, now adding that, adding this number would give you the number of vertices which are connected by removing this edge. Similarly, you can find the answer for this edge also, because by removing this or this, you will not be beneficial, because by either by removing this edge you will the graph will be connected at the end. Either by moving this edge the graph will be connected at the end, or by removing this edge graph will be connected at the end. And similarly for this and this and this and this also, which means by the beneficial case for you is by removing only either this or either this. Okay, so that's how you can solve the problem number F. Okay, so hopes you got the point. You will get the code in the description part. The understanding the code is very much easy. You can easily get it. So that's all for this video. Hopes you got the intuition of this all these problems. If you're doubting any of these 5 problems, whatever 6 problems, how many of this I don't know. So 6 problems, you can comment me down and share this video with your fellow mates. And please don't forget to subscribe my channel, and please connect to Instagram, and please connect to LinkedIn also. Till then, stay tuned for the next one. Thank you.